Good morning, everyone. My name is Amit Kumar Sen, and welcome to my next session on permutation and combination. Already, I have made 1.5 hour video on the basics on permutation combination, where I discussed about the evolution of the concept of permutation combination from the concept of numbers and how permutation combination as a topic can be used for the advanced form of counting. I believe you would have definitely gone through that video and you have understood the application of permutation and combination while solving the problem on numbers. Now, going further, if I discuss more about permutation and combination, so I want to make one session dedicatedly for the problem on dices. So, problem on dices will be applicable for the concept on permutation combination. It is again applicable when you solve the problem on probability also. The only thing in probability, so along with numerator, there's another variable which will attach, and would be the total number of cases. So basically, if you, I believe you have the fair picture about probability in your mind. So when we talk about probability, so probability is nothing but it is a fraction which talks between a number between 0 to 1, where probability is basically it is a ratio of favorable outcome divided by the total outcome. So that is basically a probability. It gives you value between 0 to 1. So you know this fact. So in permutation and combination, what all we are calculating, so that will be helpful for working on the favorable case determination when we work on the concept on probability. So this the determination of the numerator of your probability, which is your favorable outcome in the context of probability, which is actually what we are calculating in permutation combination. Okay, so talking in the context of dice, I believe you are clear with the fact that in the case of dice, when I talk about dice, so in case of dice, the total outcome, whenever I talk about total outcome, so in case of dice, the formula of total outcome is 6 to the power n. So when if I talk about the total outcome, if two dices are there, then total outcome would be 36. If three dices are there, then the total outcome would be 216. Four dices are there, then the total outcome would be 1296. So we are clear with the fact. So more than four dice, you will not get a problem. Maximum problem what you can get in a competitive exam, maximum it would be four dice problem. Now, going further on the dice problem, one dice I believe everyone can do and all. So there's no point discussing about one dice problem. Now, if I talk about two dice problem, two dice problem, you can solve it manually. Solving two dice problem is not at all difficult thing, but even then you can remember the shortcut approach that the minimum sum what you will get in two dice is 2, then it can be 3, or it can be 4, or it can be 5, or it can be 6, or it can be 7, then some can be 8, it can be 9, then it can be 10, then it can be 11, or then it can be 12. So this way you can do this. So the sum, 1 minute, it's a little bit dispatched. So now this right here 6, then it looks better. Then this is 7, and then this is 8, this is 9, this is 10, this is 11, and this is 12. Now talking about the value on sum, so you can understand this. So this follow this pattern. So symmetry, it follow this symmetry. So it follow this symmetry. So this way, if you know this, you can solve the problem very easily. So you don't have to struggle whenever you see two dice problem, thinking about the possible cases and all, talking about two dice are rolled together. What is the probability that you will get a sum at least 10? What is the probability that you will get a sum at least 10? So the answer is nothing but 3 plus 2 plus 1, that is 6 divided by 36. That very easy. So you then, if I am asking you sum at least 10, then you don't have to waste your time thinking on the cases 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. Then you don't have to waste your time thinking about all such cases. You don't have to think about all such cases where you can get the sum as 10, 4 comma 6, 6 comma 4. All that you don't have to do. So like that. So either you can waste your time thinking about, if I talk about that in how many ways can you get the sum 10 in when you roll two dice, then you think, okay, fine, then 4 comma 6, 6 comma 4, 5 comma 5, then 5 comma 6, 6 comma 5, then 6 comma 6. Then you will, okay, fine, 6 cases are there, okay, fine. So the probability is 6 by 36, or the favorable case is 6. You don't have to do all this. You just keep this symmetry in your mind. You can solve the question very easily, and that way it can helpful for you. Talking about three dice problem, if I talk about three dice problem, if I talk about three dice problem, so three dice problem, you can remember a three dice problem like this. Now if I talk about three dice problem, so if I talk about three dice problem, so if I talk about three dice problem, you can keep this in your mind. For the sum value, so the minimum sum will be 3, and it can be 4, it can be 5, it can be 6, it can be 7, it can be 8, it can be 9, it can be 10, it can be 11, it can be 12, it can be 13, it can be 14, it can be 15, it can be 16, it can be 17, it can be 18. Now, when you talk about three dice problem, when we are dealing with three dice problem, when I talk about sum, if I am talking about sum, so then it would be 1, 3, 6, then 10, then 15, then 21, then 25, then 27. So again, this would be like this: 1, 3, 6, 10, 15, 21, 25, 27. So if you remember this, you can solve this question, a three dice problem, whenever you get in competitive exam. You can solve it very easily. It won't be a big problem for you to solve it. Imagine if I am not aware about this. So if I ask you that when three dice is rolled, so when three dices are rolled, when three dices are rolled, imagine if I ask you, so in how many ways, in how many ways, in when three dice are rolled, so then in how many ways can you get the sum as 10? Can you get the sum on three dice, sum on three dice as 10? If I ask you now, imagine if you don't know the shortcut formula and all, and you want to do through the context of numbers, so then you think about the cases. So how many cases can I draw? So I'll think about cases. So 1 comma 1, will it work? No. The 8, so 8 I can't get on dice. Okay, so 1 comma 1 is not working. Okay, then 1 comma 3, 1 comma 3, 1 comma 3 is 4, then this 6. This can be one of the case. So total number of case would be 6. This total number of case would be 6, 3 factorial. I believe you know this fact. Now going further, if I think about the other case, so what can be the other case? It can be 1 comma 4 comma 5. This can be again 6. Then the third case would be then 1 comma 5 comma 4. No point of writing, duplication will happen. So with 1 you can do this. Now if I talk about 2, so with 2, 2, 1, 2, 1, 3, 7 not possible. Then 2, 2, 6. This is 3 cases will be there. Okay, so you know 3 factorial by 2 factorial. Then I'll go ahead. Then I'll think about the next case. So that can be 2 comma 3 comma 5. That would be 6 cases. Then 2 comma 3 comma 5. Then it can be 2 comma 4 comma 4. Total number of cases would be 3. Total number of cases will be 3. Okay, then 2 comma 5, don't know, because again the duplication is happening. So now the next, if I start with 3, so 3 comma 1, 4, 4, then 6. So 3 comma, okay, 3 comma 1 comma 6 already I've used. Okay, then 3 comma 2 already I used. Then 3 comma 3. So 3,36, then 4. So the total number of cases would be 3. Then 3 comma 4 comma 3. So that is not possible. So that is same thing. So 3 comma 5 again we have used. So the moment you start getting duplication, no need to try it. Now I'll start with 4. So I'll start with 4. So with 4, 4 comma 1 already I've done. 4 comma 2 already I have done. 4 comma 3 also I have done. Now talking about 4 comma 2 already I have done. 4 comma 5 already I have done. 4 comma 5 already I have done. Then 4 comma 6, 4 comma 6, 4 comma 6. If you do 4 comma 6, where they will put the third one? So that is not possible. So with 5, with 5, 5 1 already I have done. 5 2 already I have done. Then 5 3, 5 1 already I have done. 5 2 already I have done. 5 3 also done. 5 4 also means I think this would be the total number of cases if you do the sum. So frankly I would be in advantage situation because I know the answer is 10. Imagine if I'm not aware the answer is 10, then it could be a little bit of brainstorming for me to again reconfirm my value. So let's do the sum. I don't know. Still, I don't know. Did I get the sum 10, 27 or not? 6 plus 6 is 12. 12 plus 3 is 15. 15 plus 6 is 21. 21 plus 3 is 24. 24 plus 3 is 27. Okay, that means so this would be the total number of cases. So the total 27 cases is possible. Same thing if I ask in probability, the answer would be 27 by 216. Fine. So dissolving it all, you can do divisible by 3 and all. I that part you take care of that part. Okay, so I'll not use my brain for that. Okay, so 9 8 is 72. So 27 8 is 56. Then 56 5 carry 16 plus 5 216. Okay, 1 by 8 is the answer. So anyway, going further, this the same problem you could have done in other way also. So whenever you got three dice, sum should be 10. Three dice, the sum, the three dice, the sum should be 10. The three dice, the sum should be 10. So this what you can do, you can break the problem as one dice plus two dice problem. You can break this problem as one dice plus two dice problem. So one dice and two dice problem. So think in one dice, if you get the value 1, in one dice, if you get the value 1, in one dice, if you get the value 1, this one case. So here how much you should get on two dice, the sum. So on two dice, you should get the sum, as 9. So think about how many ways, number of ways. On two dice, in how many, like sum 9. So on two dice, the sum 9. On two dice, the sum 9. In how many ways you can get 4. So if you know that, this would be 4 way. The number of ways would be 4. Then if one dice, if you get the value 2, then here it should be 8. So in how many ways? So you can, how many ways means, if sum 8 means the number of ways is 5. Then third, in one dice, if you get 3, then you should get 7. 7 means how many ways? 6 ways. Okay, already you know that shortcut. So here 4, this is 6 means 5 way. Then this is 5. Then this is 5. Then how many ways? 5 comma 5. This is 4 way. Then F. Then 6 means 4. Means how many ways? 3 way. So if you do the sum means what? So this is 6 4 10, 10 14 19, 19 22 27. So this way you can solve this question and you can get the answer very easily. Fine. So this can be the another approach. So I told you 2 ways to get the same answer, not the 2 way, third 3 ways. First I told you the shortcut way to solve 3 dice problem. Then I told you a manual way which you can do by using trial error method, by using the application numbers, or you can do like this way. So 3 ways already I've told you. Now I'll tell you the fourth way of solving the same problem. In order to do that, we'll apply multinomial theorem. So the same problem can be solved by applying multinomial theorem. So you can prove multinomial theorem. You can use multinomial theorem to solve these kind of problems. So basically, what happens? The partition rule, which I have discussed in the first session. So if you remember, when I talk about distribution spelling. So if I talk about distribution of n identical object, if I talk about distribution of n identical object if I talk about distribution of n identical object into r distinct places. So when I talked about distribution of n identical object into r distinct places, so then I told you a formula for that. That formula I told you is n plus r minus 1 cr minus 1. So then this is called partition rule also. This is called as partition rule also. So this partition rule cannot be used to solve the problem on dices and all, because you need to understand in dices, if I'm writing, when I talk about dice, in case of dice, if I'm talking about dice, so if I write in the term of equation, in case of dice, if I'm writing the term of equation that x1 plus x2 plus x3 is equal to 10. So in case of dices, if I'm writing in the term of equation that x1 plus x2 plus x3 equal to 10. So here we need to understand the value of xi, what I'm taking, the value of this, this value should be between 1 to 6. This value cannot be more than 6. So here the partition rule you cannot solve the problem by using a partition rule. So then you need multinomial theorem to solve the problem. So so this is the discussion about a multinomial theorem, which you can use in permutation and combination. So 1 minute. So please have a look on this. By that I'll drink water. So this is so basically when we talk about solving the problem, uh, so so if I'm discussing the application of multinomial theorem and in solving the permutation combination form problems, you need to remember the concept what I'm discussing here. So here we use this formula that what is the application of x to the power r in the expansion of 1 minus x to the power minus n, and that is equal to this. This is very important. This is the formula what we use. So whenever I have to determine the coefficient, so here if I have to determine the coefficient, this should be coefficient. So the of coefficient of x to the power r, the coefficient of x to the power r in the expansion of 1 minus x to the power minus n, and that is equal to n plus r minus 1 cr. This is a formula what we are going to use to solve the problem on multinomial theorem. And the multinomial theorem will help us to solve many numericals which your partition rule cannot help you to solve it. So that way a multinomial theorem would be very helpful for you. So in that, let me discuss the application of multinomial theorem in this problem, the same problem. The sum on 3 dice is 10. You know the answer 27. So now let's discuss this, the fourth application of using this concept. So let's learn this concept through the application of multinomial theorem. So whenever we apply multinomial theorem, what we need to do, we need to assume a random variable called x. Whenever we are applying a multinomial theorem, we need to assume a random variable called x, and that x that let me write it down here. So if you are applying multinomial theorem, so you let assume a variable called x. So what that variable x can do, that variable x can take values that variable x can take values. So it can take value from what? It can take value from 1 to 6. So I'll write this. So the usual way of writing this is this. Now you'll write this like this. So you'll write coefficient of x to the power 10, because you want the sum to be 10. So what you will do, you will do homework to determine the coefficient of x to the power 10. So that homework you will try to do. So in that homework, the objective would be to find the coefficient of x to the power 10. So that you will search here in x1. So that x1 can take value from 1 to 6. This x1 can take value from 1 to 6. This x1 can take value from 1 to 6, because these are the possible outcome. So this is the value what x1 can take. The first dice can take. This is the first die can take. Then similarly, the second dice can also take 1 to 6 values. Similarly, the third dice can take 1 to 6 values. Whatever the value the dice can take, we represent those values in the term of power. So we'll work on this concept. So the coefficient of x to the power 10 in this is the set of random possible outcome on one dice. So similarly on second dice also you'll get the same answer. For third dice also you get the same answer. So this is nothing but if I all together on 3 dice, if I ask you all together on 3 dice, if I ask you, so the set of all possible outcome would be this x to the power 1 plus 2 plus 3 till x to the power 6. So this would be the set of all possible outcome on the 3 dice all together, where the sum should be 10. So the everything either its outcome, or either the set of variable which that variable can intake, all we consider in the term of power. So now the same thing I can write as coefficient of x to the power 10 in, so this I can write x to the power 1 plus 2 plus 3 plus 4 plus 5 plus 6 to the power 3, considering all the 3 dice 1, dice 2 and dice 3 all together. So then I can keep solving this. I need to find the coefficient of x to the power 10 in. So now if you notice they are in GP. So you can write them in the form of GP. So if you write them in the form of GP, this is a into 1 minus r, the r divided by 1 minus r to the power 3. Okay, so you can write them in the form of GP. So I can write this coefficient of x to the power 10. So you little bit of basic knowledge also if you have of binomial theorem, that would be more than enough. So this would be x to the power 3 into 1 minus x to the power 6 to the power 3 into 1 minus x to the power minus 3. So then this is nothing but this is coefficient of, so if you understand, I'm looking for the coefficient of x to the power 10, and here if you notice, here I'm getting x to the power 3, means out of the 10 values what I'm looking for, the 3 values already I got. So other way I can write, I need to search now coefficient of x to the power 7 in 1 minus x to the 1 minus x to the power 6 to the power 3 into 1 minus x to the power minus 3. Okay, then going further, I can write, I need to search the coefficient of x to the power 7 in, so I can solve this. I can find the value. What is 1 minus x to the power 6 ka whole cube? So that would be a cube minus b cube, a cube minus b cube, a cube minus b cube minus 3a square b minus 3a square b minus 3a square b plus 3ab square. So this way 1 minus x to the power minus 3. Now I'm looking for a power called x to the power 7, and in that this any power which is more than x to the power 7 will not be significant for me. So this power like x to the power 18 is no ways gonna help me. Neither the x to the power 12. So the value what is going to help me to search for the value called x to the power 7. So that would be nothing but, so only two values can help me. So what power should I consider? So here I just need to focus on these two power, because these two power can only help me. Either they are either one, either it is 1, or either it is 3 to the power so minus 3 into x to the power 6, because any power which is greater than x to the power 7 is definitely not going to help me to figure out the coefficient of x to the power 7 in that. So I hope you can understand this. So going further, what I can do, so I can solve this further. I can write coefficient of x to the power 7 in, if I open the bracket, so I'll get 1 minus x to the power minus 3 minus 3 this x square into 1 minus x to the power minus 3. So now I can go further and I can search for coefficient of x to the power 7 in 1 minus x to the power minus 3 minus of 3, and then here if I search here, so then I can search for here coefficient of x to the power 7, coefficient of x to the power 7 in x square 1 minus x to the power minus 3. Fine. So now if you understand this, now you can apply the formula, the formula which I told you in the beginning, that the coefficient of x to the power r, coefficient of x to the power r in 1 minus x to the power minus n is n plus r minus 1 cr. This is a formula what I told you in the beginning. Now you can apply that same formula here. So if you apply the same formula here, then in that context, your r would be 7, and your n would be 3. Okay. So what is the coefficient? So the coefficient of, so you need to understand. So the coefficient, of x to the power 7, in 1 minus x to the power minus 3 is basically, that is 7 plus 3 minus 1 c7, okay, minus 3. Now if you understand here, you are looking for coefficient of x to the power 7. Here already x to the power 6, means you now have to search only x. So you can write this is nothing but, this is coefficient of x in 1 minus x to the power minus 3. Okay. So in here, your r value, so this is, if you understand, here your r value, r value is 1 and n value is basically 3. Okay. So now going further, so you can say finally your answer is coefficient of x to the power 7 in 1 minus x to the power minus 3 is basically 9c7 minus 3 into this will be the coefficient of x to the power x in 1 minus x to the power minus 3 is basically 1 plus 3 minus 1 c1. So by then you can say this is nothing but 9c2. So ultimately your answer would be 9c7 minus 3 of 3c1. 937 is 9c2 minus 3 of ec1 is 3. 9c2 is 36. 36 minus 9. So you get the answer called 27. This is the application of a multinomial theorem to solve the problem on dices. And if you apply a multinomial theorem you can get the answer like this. So this is just an understanding. So if you develop this understanding, multinomial theorem will definitely will be applicable for many such problems, which normally the usual formulas will not able to give you. So whenever you have confusion on that part, you can definitely apply multinomial theorem to solve the question on permutation combination. So for that, you develop a basic understanding of binomial theorem. I think that will serve the objective. So similarly, if I talk about a four dice problem, four dice problem, so you can solve a four dice problem considering one dice and three dice. So whenever you get the four dice problem, so break the four dice problem as one dice plus three dice, one dice plus three dice, and that way it can help you to get the answer. So manually I can determine that part also. So that I need to sit and I need to work on. So the minimum sum, like when you talk about the sum on four dice, when if I talk about the sum on four dice, so that would be from 4, 5, 6, 7, 8, 9, and that would be from 4 to 24. That will be from 4 to 24. The sum on four dice, that will be from 4 to 24. So you can manually do that. I can three dice already I told you. So three dice already I told you. So 4, 5, 6. You can, if you sit and if you keep writing the values, you can easily get that value very easily. Let's solve one problem for a better understanding. So in how many ways? In how many ways can I get a sum of 15? Suppose sum of 15 when four dice are rolled together. So when four dice are rolled together, so rolled together, so you can do this. So what I can do, I can break this problem as one dice plus three dice. You can break this problem as one dice and three dice. So here if I take a value 1, so I want sum 15. So on 3 dice, I want the sum to be 14. So the number of ways this is possible. So on 3 dice, the sum 14. So the number of ways this is possible. So for the 14, the number of ways this would be 15 ways. Okay, so you can see that you can see this shortcut table what I've drawn. So for this 14, you can see the number of ways to get the sum 14 would be 15 ways. So you can remember that way. If you remember, then your work will be done. Okay, so then in one dice, if you get 2, then it should be 13. Number of ways of 13 is 21. Then on one dice, if you get 3, then it should be 12. Then the number of ways is 25. Then on one dice, if you get 4, then it should be 11. The number of ways is 27. Then 5, you get almost 10. Number of ways for that is 27. And then for 6, here if you get 6, then this should be 9. 9 for 9, this should be 25. Number of ways, so that would be 25. For the 9, that would be 25. Now you do the sum. So on 4 dice, in how many ways can you get the sum 15? So just you need to do this calculation. So 5 plus 5, 10, 15, 15 plus 14, 15 plus 15 means 15 plus 15, 30. 3 carry 3, 4, 6, 8, 10, 12, 14, 140. So number of ways you'll get is 140. If I ask in probability, the answer would be 140 by 1296. Okay. Now the same thing if I solve manually. So manually if I solve this, 4 dice. So 4 dice, the sum should be 15. In how many ways this is possible? So let's try with 1. 1 1 1 1 1 1 1, so definitely not going to work for me. Okay, so I want the sum 15. So 1 1 2, will it work for me? Like this would be a little bit difficult to analyze the cases. So 1 1 2, so 4 means 11 not gonna work. So 116 means 8 7. So 1 1 to definitely not gonna work for me. So because then on 2 dice I should get some 13, that is not possible. So then on 2 dice I should get the sum 1 1 means then 2 dice I should get the sum 13. On 2 dice the maximum sum can be 12. That is not gonna work for me. 1 1 is not gonna work for me. Let's try 1 2. If I try 1 2, if I try 1 2, then on 2 dice I should get the sum 12. On 2 dice I should get the sum 12. So 12 means 6 comma 6 comma. This is 6 comma 6. That is only one way is there. So that is the only one way I can get the sum 12. So this 6 12 14 15. Uh, so this, how many ways this is possible? So 4 factorial by 2 factorial, that is 24 by 2 means 12. That is 24 by 2 means 12. Okay. Then next case. Then so this is 12 way 1 comma 2. So what can I do? So so with 1 comma 2 there's only one way. Okay, so with 1 comma 2 there's only one way, 12, to get the sum, that is 6 comma 6. I cannot think about any other thing. So 1 comma 2 5 comma 6, all that I can't do. So I'm stuck. If I'm taking 1 comma 2, then I can't do anything else. So there's no other way I can do. So let's try 1 comma 3. So if I take 1 comma 3, so means then I should get remaining sum as 11. So 11, two ways are there for 11. That is 5 comma 6 and 6 comma 5. This is 4 factorial. That is 24 way. Okay, so 1 comma 3 comma 5 comma 6. So you got this. Then so with 1 comma 3, so 11, 11 can be 5 comma 6 or 6 comma 5. So there's no other way I can think on this part. 11, 11, when you talk about 11, so there's no other way I can think about it. So then if I talk about 1 comma 4, so if I'm talking 1 comma 4, then if I'm talking 1 comma 4, then so the sum should be 10. So sum should be 10 means 1 5 comma 5. This is again 12 base. So then I can think about 1 comma 4, then 4 comma 6. So this is these all the possible way. So this is again 12. Okay, then with 1 comma, I think sum 10, these are three ways are there to get the sum 10. Then if I think about 1 comma 5, I think about 1 comma 5, then 1 comma 5 means you should get the sum 9. So for sum 9, for sum 9, you get 3 comma 6, 3 comma 6. So this is 24 way, or 3 comma 6, 3 comma 6. Then you can do 3 comma 6, not no 1536, already it came, already you have used here. You can see 1536 already you have used here, already you have used there. Uh, then 1 comma 5 comma then 9 na. So 9, what is the other way? 3 comma 6, 6 comma 3, then 4 comma 5, 1 5 5 4 4 4 comma 5. So then that is also you used. So 1554, so that is also you have used. Okay, so then I really doubt then what you can think about. the other cases, what you can think about the other cases. So 1 comma, then so 4 comma 4, 9 you want, no? 4 comma 5 already. So 1 4 4 5 already you have done that. 1 5 5 4. So that way it's not gonna work. So 3 comma 6, 3 comma 6, 4 comma 5, and then so this would be 3 comma 6, 4 comma 5, 4 cases. So I think this then 1 comma 6, if I take 1 comma 6, so already I have used 1 comma 6, so that you can see already I have used. So with 1 comma 6 you will get the sum 8. So 1 comma 6 you will get the sum 8, and 8 8 already we have tried, that is 1 2 6 6. Then 8 I have tried 4 4. So these are 2, then 8 already I've done that. So this is done with 1, this I'm done with 1. So now I can think about 2. So with 2, what I can think about with 2, with 2 I can think what I can think about 2, with 2. So with 2, uh, so with 2, what can I think with 2? So imagine randomly, this is the easy way. So 6663. This is how many way? 4 factorial by 3 factorial means 4 way. Six, no, no. Sorry. So this is what I wrote. 15 I want to 6. So 15, 15 is not gonna work like that way. So 4 comma 4 comma 4. So 12 and then 3. Then 4 comma 4 comma 4 then 3. So 12 then 3. This I have not used. This is 4 way. Okay, then 4 factorial by 4. So here what else I can do? So so with 1 I'm done. With 2 2 1 already I've tried. Then 2 2. 2 2 means 4. So 15 minus 4 11. So 2 2. So let's talk about 2 2. So let's talk about 2 comma 2. So when I talk about 2 comma 2, if I talk about 2 comma 2, so I get 4. So means 4 means 11. 11 I should get the sum. So 11 means 5 comma 6. So this is 12a. Then 5 comma 6, 6 comma 5. So that done with that. So this is 4, 10, 15. Okay. Then 2 3. 2 3 have I used till now? 2 3. 2 2 I've done with 2 2. Now 2 3 I've not used. So 2 3. If I talk about 2 3, so 5, 10. 10 means 5 5. So 10 means 5 5 I can take. 2 3 5 5 I can take. So 2 3 5 5 if I take. So 10 15. So this is what this is again 12. This is again 12. So this I can do. This I can do. Okay, so this I can do 2 3 5 5. So 2 3 5 5. Then with 2 3 10 10 4 6 2 3 4 6. With 2 3 4 comma 6. This would be 24 ways. Okay, 2 3 4 comma 6. So this is 10 15. So 2 3 4 comma 6. So 15 ways this is possible. Okay, uh, so uh, so 2 3 4 comma 6. So you the 10 10 when I talk about 10, so 10 is okay, this done with 10. So I'll talk about 2 4. So if I talk about 2 4, I have a used 2 4. So 2 4 I have not used. 2 4, okay, I've used just now. I used 2 4. So 2 4 I cannot use. Then 2 5, 2 5 already I used. 2 6 already I used. So then I talk about 3. So E F G H H I. Then Then if I talk about 3, so 3 1 already done, 3 2 already done, 3 3 3 3 6, 6 means 9. 9 you want the sum. So 9 means 3 3 4 5. 3 3 4 5. So 3 3 4 5. Just check 3 3 4 5. 3 3 4 5. So you're not used. So then 3 3 5 5. 3 3 5 5. 9 you want, no? So not 3 3. 9 means what? 4 comma 5, 5 comma 4, then 6 comma 3. 3 3 3 6. 3 3 6. 3 3 3 6. So you can E F G H I J, then 3 3 3 6. You can use this. So 3 3 3 6. This would be 4 ways. 3 3 3 6 would be 4 ways. Okay, so with 3, you done with 4 5. You did 4 5. Then 3 6. Then with some 9 4 ways are there. These are the 4 ways I'm done. Then 3 4 I'm done. 3 5 I've done. 3 6 I'm done. So with 4 4 4 already I tried 4 4. Then 4 5. 4 5 already I tried. 4 6. 4 6 already I tried. Then with 5. With 5. With 5. So with 5 5 1 already I tried. 5 2 already I tried. 5 3 already I tried. 5 3 already. 5 4 already tried. 5 5 10 10 5 5 1 minute. 5 5 10. Then 5. 5 means 1 comma 4. 5 5 1 comma 4 that I did. Then 5 5 1 comma 4. Then 2 comma 3 also I tried. Then with 6 6 also I think I've tried. So let me do the sum. So this is 3 4 5 6 7 9 10 120 120 120 plus 8 128. Okay, so it is 128. I should get the answer called 140. This is 128. No? So this is 12 ones are well. This is, you can do this sum. So you can do this sum to get the value. So you can do so 6, 8, 10, 14, 16, 18, 20, 24, 28. 28 to carry 2, 3, 5, 6, 7, 8, 9, 10, 12, 128. So still I'm looking for what value? 12 value, 128. So one I'm missing with 1, where the two values should repeat. So one value I'm missing with 1. So 666 12. 666 12. So IJK. So 666 18. I'll get no 66. I want 15. So 66 12. 3 I want. 1 comma 3. Okay, 66 12 na 3 I want. 3 means 1 comma 2 or 2 comma 1. That part I've done. That part I have done. So with 6 that part I have done. So 3 means what? Sum 2v3. Only one way. Sum 2v3. What's it? Non 2 dice. 2 ways is there. So 1 comma 2 or 2 comma 1. So that there's no other way for that. So with 6 comma 6, there's no point. Uh, so with 6 you tried 1. With 6 you tried 2. With 6 you tried 3. Then with 6 you tried 4. With 6 you tried 4. With 6 you tried 5. Okay, so 1 minute, just confirm this. So this is 4 factorial by 2 factorial, 24 by 2, 12. And this is 24. Then this is 12. Then this is 12. then this is 4 factorial by 3 factorial, that is 4. This is 12, this is 12, then this is 24, this is 12, then this is 4. Okay, so one case I'm missing here. So we can think about one case with 1 to not possible. No, 1 means you get the sum 13 on 2, that not possible only. 1 2 I did with 1 2. So with 1 2, this is the problem what we face here with 1 2. So if I think about the case with 1 2, so 1 2, so with 1 2 12, with 1 2 12, 3 you got the 12. So 1 2, you got the 12. Then 1 3, with 1 3, you got this. Then with 1 4, with 1 4, the total number of cases is 3. That also you got. Then 1 5, 1 5 already you're done. 1 5. If you try 1 5, then you get the sum 6. 6 means what? 13 minus 6, 9. 9 with 1 5, 1 minute. I'm just trying. So with 1 5, I should get the sum as 9. So 9, 4 ways are there for 9. So 1 5, 4 ways are there for 9. So 1 5, 4 ways are there for 9. So 4 ways are there for 9. So if I'm talking on 1 5, here you can see 1 5. This you got 9. 1 5, you got 9 here and there. 4 ways are there, both you used. So that is not possible. So this is not possible. 1 5 not possible. Now 1 6, with 1 comma 6, 1 comma 6, 7. 15 minus 7, 8. So with 8, 5 cases are possible. With 1 comma 6, 5 cases. 7 means 8. 8 means 5 cases are possible. So 5 cases are possible. So 1 comma 6, 5 cases are possible. 1 comma 6, 5 cases are possible. 1 comma 6, 5 cases are possible. So you got these two case, 2 2 4, then 5. Okay, so 1 comma 6 is also not possible. So 1 comma 6 is also not possible. So 1 comma 6 also not possible. So then okay, 1 minute. Let me do this sum again. So you want the sum 15, no? So 14, 14 means 15 way. Then 13 means 21 way. And then 12 means 25 way. And then 12 means this is 14. 14 means 15 way. And then 13 means 21 way. And then 12 means 25 way. And then 11 means 27 way. And then 10 means 27 way. Okay, and then 9 means 25 way. 9 means 25 way. Okay, correct. So this sum is 5 plus 1 6, 6 plus 5 6 plus 5 11, 11 plus 7 18, 18 plus 7 18, 25, 30, 3 carry 3 4 6 8 10 12 14. This is correct. So here what else cases is there? 1 I'm done with 1. With 2 1 not possible. 2 2 2 2 already I tried. 2 2 means 4. 4 means 15 minus 4 11. 11 means 11 means 2 cases are there. So all that I had done. Then I did with 2 3. 2 3 means 10. 10 means 3 cases are there. So that I've done. Then 2 4, then 2 4, then here 2 4 I j k 2 comma 4 6, so 9. uh, so 2 comma 4, so you got 9. So 9, with 9 4 cases are possible. So 2 4 9, that 2 4 9, 9 means 3 comma 6, and 9, and then 4 comma 5. Is this anywhere repeated? So 2 4 4 5, this is 6 6 plus 4 10 15. Let's just check 2 2 2 4 4 5, 2 4 4 5, anywhere repeated. Let me confirm. 2 4 4 5, 2 4 4 5, 2 4 4 5. Not here, not here, not here, not here, not here, not here. 2 4 4, not here, not here, not here. Now 2 4 4 5. So 12 cases are there. So the total, this would be 140 cases. So like this, you have to think to get the answer. So now the same, now the same logic you can use here also, for by using, you can solve the same problem by using multinomial theorem, not monial, it's nomial theorem. So sum on 4 dice, it should be 15. So what you need to do, you have to search for the coefficient of, x to the power 15 in, the value should goes from 1 to 6. In dice, the value should be from 1 to 6. Okay, and then the 4 values are there, 4 dice, so this should be power 4. This should be power 4. To search the coefficient of x to the power 15 in, if you write in GP, this would be x 1 minus x to the power 6 by 1 minus x. This would be to the power 4. This you can write a into 1 minus r to the power n divided by 1 minus r. So you can write this as coefficient of x to the power 15 in x to the power 4, 1 minus x to the power 6 to the power 4, 1 minus x to the power minus 4. Okay, so already you got x to the power 4. Now you need to search for coefficient of x to the power 11 in 1 minus x to the power 6 to the power 4 in 1 minus x to the power minus 4. Then I'll split this 1 minus x to the power 4. So I believe we know the formula. This we know what is a plus b to the power 4. So that is a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power 4. So it means I need to search for the coefficient of x to the power 11 in, this is a to the power 4 minus 4a cube, a cube b, a cube b, a cube b minus 4a cube b. B is odd here. So then plus minus, then plus 6 a square b square, b square means 12. Then minus 4 a b cube. B cube is 6 to the power 18. Okay, then plus b to the power 4 means x to the power 24 into 1 minus x to the power minus 4. So this you need to search. So now here I'm looking for coefficient of x to the power 11. So what all are significant for me? This is significant, this is significant. Then remaining all are greater than 11. So they are not at all significant to me. So I need to search coefficient of x to the power 11 in, I'll write this because why to waste my time writing all together, because anyway they'll give me coefficient bigger than 11. So anyway that is not possible only that they can give me the coefficient of x to the power 11. This minus 1 minus x to the power minus 4. So why should I waste my time writing all the possible coefficients of x? Because any coefficient, any power of x which is more than 11 is not at all significant for me. So I can write this as coefficient of x to the power 11 in, this is 1 minus x to the power minus 4 minus 4. This you can understand x to the power 6. So no need of writing this again. So 6 means 5 I need to search. I need to search now coefficient of x to the power 5 in 1 minus x to the power minus 4. Okay, so now you can understand here. So here the N1 is 4 and R1 is 11. Here you need to understand that your N2 is 4 and R is 5. So 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 you, so you what you need to search, you know the formula, again the same formula, that coefficient of x to the power r in 1 minus x to the power minus 1. So the coefficient of x to the power r in the expansion of 1 minus x to the power minus n is n plus r minus 1 cr. So this, that way if I use this, so the here uh, so here the formula, if you apply, so if you apply the formula, so then it becomes n plus r minus 1 cr. That is a formula. So you need to understand this. So the coefficient of x to the power 11 in 1 minus x to the power minus 4 is 4 plus 11 minus 1 c11 cr. So this is 14 c11. 14 c11 means 14 c 14 c3 now. 11 minus 4 3 now. So 14 c3. So what is 14c3? 14c3 is how much? What is 14c3? That is 14 into 13 into 12 divided by 6. This is 2 za. So 13 into 14 is how much? 169 plus 169 plus 13. I think it's 182. 182 into 2. 182 means 364, I guess. The answer is 364. You can check with that. Check with calculator or whatever. So 13 into 14, 13 4s are 52, 13 1s are 13. So this is 182. 182 2s is 4, 16 364. So this is 364. So this is coefficient of this, and this coefficient would be what? This value is what? This value would be n plus r, means 5 plus 4 minus 1 cr. R means what? 5. So this is 9. 8c5. 8c5 means 8c5 is how much? 8c5 means 8c3. 8c3 means 56, I guess. 8 into 7 into 6, that is 56 only. So you need to understand, this is 364, this is 56. So if I delete this, so this is 364, so this is 56. So this is the coefficient of x to the power 11 1 minus x to the power minus 4 is how much you got? I forgot. 365 or something, no? That was 364. So 182 twos are 182 twos are 364, and this minus 4 times of, so the coefficient of x to the power of 5 in 1 minus x to the power minus 4 is how much? 86, 8c3, that is 56. Your final answer would be 364 minus 4 times of 56. So this is 364 minus 4 6 are 24, 2 carry 224. So this is what? This is 0, this is 4, and this is 1. The answer is 140. So the same answer what I got before also. So this is what you can do the same problem for multinomial theorem, or you can spend time thinking about all the possible cases, or you can solve this problem. The most easiest way to solve 4 dice problem would be consider 1 dice and 3 dice, and you will get the answer very easily. So this session, one session dedicatedly, I wanted to discuss about the problem on dices. I hope you have enjoyed learning the concept on problem on dices. I really believe that it will definitely will help you to solve permutation combination question in much more better way. So along with this, I have developed a video on dictionary problem also. So imagine if I ask you, if you make a dictionary with the letters of the word called Mississippi. So what would be the ranking of the word Mississippi in the dictionary? So the answer is around 13,737. So that these all you can spend time. You can get that video in the playlist. Please go and watch that video. Definitely, it will help you to solve the problem on ranking of words in the dictionary, and that I did with repetition and without repetition. So shortcut way also I explained the same thing, and logical way mathematically also I explained the same thing. I hope that you really love that session. So with that intention, I like to wind up this class. So thank you everyone. Take care everyone. Bye. Take care.